Happy Monday. We have to finish up USub. Sorry, we can't offer you help.
Sorry, I haven't
Now we did antiderivatives. Now we're going to use USub for integrals. There's just one additional step. What should U be? Which makes du what? If u is x minus 2, what's du?
1.
It's dx. Then what is x? However, the limits 2 to 6 were given for x. We're now in u. When x equals 2, what does u equal? When x equals 6, what does u equal? There's your new integral. Antiderivative of u to the 3 halves. Keep going. What about u to the 1 half? Well, that's with the 2, without the 2. So ignore that 2. It's just u to the 1 half. What's the antiderivative? And then multiply by that 2. That will be evaluated from u equals 0 to 4. Four to the 5 halves power is what? 4 to the 5 halves. Isn't that the square root of 4 to the 5th? It's 4 to the 5th. So square root of 1024 is what? It's obviously 32. Easier way to do it is square root of 4 and then 2 to the 5th. Which is 32. Then times 2/5. 4 to the 3 halves. It's 8. Times 4/3. 64/5 plus 32/3. $64 times 3, 192. 32 times 5. 192 plus 160. There is the integral. So again, nothing different. Except remember to convert your limits of integration. And that's true whenever you change the variable. So what's u?
Sine of x.
What's du?
Cosine of x.
Dx. When x is minus pi over 2, what's u? One. It's -1. When x is pi over 2, what is u? That's 1.
Hold on. We go back to the last example for a moment. Okay. Oh wait, no, I see what we did now. Okay. reason I thought we were plugging the limits into the original equation, not our equation for you last time.
Antiderivative of u squared. One cubed. Negative 1 cubed. 1 minus negative 1. So this integral's 2/3. It's Monday, leave her alone.
Is 1 minus x squared.
What's du?
Negative 2x. Yes.
Do you see a negative 2x dx?
No.
We do have 2x dx. So multiply the 2x by negative 1, and then multiply the result by minus 1. When x is 0, what is u? When x is 1, what is u?
Does it matter if the larger number is on the bottom?
You can. As you'll learn, that just represents a direction.
Okay. And
Right, so you start at 1 and go to 0 in this case.
direction shouldn't affect area.
No. Area is always positive. But integral's not just areas. I'm sorry, area's not. It could be assigned area, which would be negative. Oops, why do I do u to the 5th? It's u to the 4th. But there's that property that says you can flip the order of integration by multiplying by minus 1. Antiderivative of u to the 4th. This one's rather difficult. 1 to the 5th. 0 to the 5th. 1 minus 0.
1.
We're left with just 1/5. What's du? What was it? Do we have a 2x plus 2 dx? How does that help us? What do you mean put a 2 out front? And you put a 2 in front of the x plus 1, yes, but then you have to multiply your result by a half. When x is negative 2, what is u? When x is negative 1, what is u? You know, just flip the order here to make it look more natural. What is the antiderivative of e to the u? And that gets evaluated from u equals 0 to 1. What is e to the first power? E to the 0 power. One minus e over 2. How do you want to proceed? Making all the exponents what? How would you do that?
We put that whole bottom part in parentheses. Put a negative 1 is an x1 on the outside of those parentheses. Then,
How does that help us?
well, I mean, it's mathematically possible, so that's a step up.
Just because it's allowed doesn't necessarily mean it's a good thing. Right? Yes, you're right. You can do that. Doesn't help us.
I'll have to get that one. I'm at a loss for what else to do.
We would just say e is the denominator.
Then what is du? Which we don't have a 2x minus 6. Or a multiple of 2x minus 6. How would you factor it? Algebra. It's a very bad word. When you worked with when you were working in algebra and you saw quadratics, what was one thing you did?
In this case, we have to do complete the square.
Completing the square. How would you complete the square? How did you do it?
If I remember, to make C, you'd have to do B over 2 squared, subtract the original C to the other side. So it'd be x squared minus.
Do we have an equation though? And you did actually skip a step. The first thing you have to do is make sure your leading coefficient is 1. If it's not 1, your technique does not work. So you have to make it 1. In this case, it's already 1, which is nice. Half of -6 squared. We want x squared minus 6x plus 9. That would be a perfect square. But 10 is 9 plus 1. That bit there is now a perfect square.
Why is that much easier than I remember completing the square being back then?
Because you're in Calculus 1 now.
Right.
And you probably spent how many countless of hours doing it in algebra? Is dux minus what? What's du? What's the new lower limit? What's the new upper limit? What's that antiderivative?
We know how to do that.
That is the inverse tangent of u. What is the inverse tangent of 1? What is the inverse tangent of -1? So the equals pi over 2. So what are we going to do?
I'm assuming you can't just simply square the thing and remember to keep the square root of our answer later.
That doesn't work.
Is multiply by conjugate something we can do here? Multiply top and bottom by square root of 4 plus x squared. I think it's not that.
I mean, you can do that, but
Okay, so it won't help.
it doesn't matter. Like, that's essentially multiplied by 1. Right, you're allowed to do that, but it's not going to help in
Well,
this case.
is that also referred to by multiplying by conjugate? Or
That's not the conjugate here.
What would the conjugate be?
Negative square root of 4 minus x squared, technically. So what function has a derivative of that form?
I mean, the closest thing I can find to that would be the inverse sign, but the 4 is wrong.
So why not get rid of it? If it's what's causing the problem, why not get rid of it? What's the square root of 4? Now what do you want to do?
stuff outside of the integral and what we can?
Scalar multiple.
Okay. And when we move it, actually, we know that was, yeah, that 2 was always in the denominator.
Yeah, because there was a squared 4 in the denominator. A huge hint is the section that we're in.
Integrals,
But what are we doing with integrals?
we're substituting.
So if that's the section we're in, then probably substitution would be
Just trying to find a U value.
a good move forward.
We want to set U to, just throwing this out there, 1 minus squared over 4.
If you do that, what's du?
That would be negative x divided by 2.
Do you see a negative x dx?
No,
So that won't work.
can't throw that in there somehow.
Quickly, you already forgot what we're trying to get it to look like.
One look like some kind of f g times g prime.
You just told me. Inverse sine.
All right, that's what we're doing. Now it's 4.
If u is x over 2, what is u squared? X squared over 4, which is what we have, right? What's du? Du. Oh, don't we have a 1/2 dx? So why don't I just move that 1/2 inside? When x is 1, what's u? When x is √3, what's u? What's that antiderivative? Why do I put a 1/3? What is the inverse sine of √3 over 2? Inverse sine of 1/2.
I over 4. Yeah, it's 5 over 6.
What's pi over 3 minus pi over 6? There's our integral. So this just goes to show, sometimes u is going to be really obvious. Other times you have to manipulate it to find out what your u is. Finding that u is half the battle. And then just wait till you get to Calc 2. And then Calc 3 after that. That is U sub. Questions on U sub? And with that, I only have one more thing I have to cover this semester. And that's area between curves.
I don't like the sound of that.
It's fine. I prefer not to cover in Calc 1, but I have to.
I mean, as long as those curves don't intersect or something, that sounds.
Why? Intersecting curves makes it more fun,
Yeah, but non-intersecting curves.
especially if you have 5 curves that intersect, and you want to find an area bounded by all 5 curves.
Oh, wait, this is not what I thought this was. I thought we were. Yeah, I thought we were
You'll
looking
see.
for an area.
But that will be after Thanksgiving.
I thought we'd be looking for areas literally in between, the two graphs
That's what.
and ignoring the x-axis.
Well, that's what we're doing. Area between curves. But I can have 5 curves and say what's the area bounded by all 5 curves.
Can that just be the area by the 2 outermost ones?
Nope. Makes it really fun.
I don't like this.
Makes it really fun. For personal reasons, I'm going to quit early today. So do not forget, we do meet tomorrow. However, tomorrow will be for you to work on your project in class. And then same thing about Monday. Monday is just going to be project.
Oh,
So not covering anything new until next Tuesday.
those 2 days for this one. So, we have to down now. Go.
And we do not meet Thursday. So I will see you all tomorrow for time to work on your project. If you decide not to show up, have a great Thanksgiving.